Introduction. In our previous classes, we have studied about factors, multiples, prime and composite numbers, odd and even numbers divisibility tests. In this chapter, we will review about basic ideas and properties related to them. Factors and multiples. Consider the multiplication fact 48 is equal to 6 multiplied by 8. We can interpret this multiplication fact in different ways as A. 48 is a multiple of 6. B. 48 is a multiple of 8. C. 6 is a factor of 48 and D. 8 is a factor of 48. Factor. A number which divides a given number exactly is called a factor of the given number. Let us try to find all factors of 48. 48 is equal to 1 multiplied by 48, 2 multiplied by 24, 3 multiplied by 16, 6 multiplied by 8, 4 multiplied by 12. Thus, 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48 are factors of 48. Important points to remember about factor of a number. A. 1 is a factor of every number. B. A number is a factor of itself. C. Every factor of a number is either less than or at the most equal to the given number. D. The smallest factor of a given number is 1 and the greatest factor is the number itself. E. If a number is divided by any of its factors, the remainder is always 0. F. Number of factors of a number are finite. A number is called perfect number if it is equal to the sum of all its factors, except the number itself. Or, a number is called perfect number if the sum of all its factor is equal to twice the number. Example. 6 is a perfect number, as 1, 2, 3 and 6 are factors of 6 and 6 is equal to 1 plus 2 plus 3 which is equal to 6. Or 1 plus 2 plus 3 plus 6 is equal to 12 which is equal to 2 multiplied by 6. Check if 10 and 28 are perfect numbers. Multiples. A multiple of a number is a number obtained by multiplying it by a natural number. Example, 5 multiplied by 7 is equal to 35. Here, 5 and 7 are factors of 35 and 35 is a multiple of 5 as well as 7. The product of two numbers is a multiple of both the numbers multiplied. Multiples of 7 are 7, 14, 21, 28 and so on. Multiples of 11 are 11, 22, 33 and so on. We can see that multiple of a number is always greater than or equal to the number itself. Important points to remember about multiple of a number. A. Every number is a multiple of 1. B. The smallest multiple of a number is the number itself. C. We cannot find the greatest multiple of a number. D. Number of multiples of a number are infinite. Example 1. Find all the factors of 36. Solution. 36 is equal to 1 multiplied by 36, which is equal to 2 multiplied by 18, which is equal to 3 multiplied by 12, which is equal to 4 multiplied by 9, which is equal to 6 multiplied by 6. We continue this process till we get the same multiplicand. So, 1, 2, 3, 4, 6, 9, 12, 18 and 36 are all the factors of 36. Example 2. List all the numbers less than 100 that are multiples of A. Both 2 and 5. B. 2, 3 and 5. Solution. A. Multiples of both 2 and 5 is equal to multiples of LCM 2, 5 equals to 10. Multiples of 10 less than 100 are 10, 20, 30, 40, 50, 60, 70, 80, 90. B. Multiples of 2, 3 and 5 is equal to LCM 2, 3, 5, which is equal to 30. Multiples of 2, 3 and 5 less than 100 are same as multiples of 30 less than 100. That is 30, 60, 90. Prime and composite numbers. We know that every number is divisible by 1 and number itself. Thus, every number except 1 has at least 2 factors. The natural number 1 is the only number which has only one factor, that is 1. Thus, we can classify numbers in two groups, that is, prime numbers and composite numbers. Prime numbers. Those numbers having exactly 2 factors are called prime numbers. One factor is 1 and other factor is the number itself. Examples of prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23 and so on. Smallest prime number is 2. Composite numbers. Those numbers having more than 2 factors are called composite numbers. Smallest composite number is 4. Some important points about prime and composite numbers. A. 2 is the smallest prime number. B. 2 is the only even prime number. Other prime numbers are all odd. C. 1 is neither prime nor composite. D. Smallest odd prime number is 3. E. The greatest one-digit prime number is 7. Co-prime numbers. Two numbers are said to be co-prime if they do not have a common factor other than 1. Example, 2, 3, 3, 4 and 3, 11, etc. are co-prime numbers. A. Any two prime numbers are always co-prime. Example, 5, 7 and 11, 19. B. Two co-prime numbers need not be both prime numbers. Example, 6, 7, 14, 13 and 27, 16. Example 1. Write 7 consecutive composite numbers less than 100 so that there is no prime number between them. Solution. These are 90, 91, 92, 93, 94, 95 and 96. Example 2. Write 5 consecutive composite numbers lying between 73 and 80 so that there is no prime number between them. Solution. These are 74, 75, 76, 77 and 78. Example 3. Number 13 and 31 are prime numbers. Both these numbers have same digits 1 and 3. Find such pairs of prime numbers up to 100. Solution. 37, 73, 17, 71 and 79, 97 are 3 such pairs. Example 4. Give 3 pairs of prime numbers whose difference is 2. Solution. A. 3, 5 are 2 such prime numbers. B. 5, 7 are 2 such prime numbers. C. 11, 13 are 2 such prime numbers. 2 prime numbers which differ by 2 are called twin prime numbers. 3, 5, 5, 7, 11, 13 are pairs of twin prime numbers. Test for divisibility of numbers. To check the divisibility of one number by other, we normally perform actual division and see whether remainder is 0 or not. But the divisibility test helps us to check the divisibility of a number by certain numbers like 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Number. Rule. 2. When the digit at one's place is 0, 2, 4, 6 or 8. 3. When sum of all digits of a number is a multiple of 3. 9. When sum of all digits of a number is a multiple of 9. 6. A number is divisible by 6 if it is divisible by 2 and 3 also. 4. The number formed by last two digits is divisible by 4. 8. The number formed by last three digits is divisible by 8. 5. When the ones digit of the number is either 0 or 5. 10. When the ones digit is 0. 11. When the difference between the sum of its digits in odd places and in even places is either 0 or a multiple of 11. 7. When the difference between twice the digit at one's place and the number formed by other digits is either 0 or a multiple of 7. Example 1. Check the divisibility of 17,90,184 by A. 2, B. 3, C. 4, D. 6, E. 7, F. 8, G. 9, H. 11. Solution. A. 17,90,184. Digit at one's place is 4, so it is divisible by 2. B. 17,90,184. 1 plus 7 plus 9 plus 0 plus 1 plus 8 plus 4 is equal to 30. 30 is a multiple of 3. So, 17,90,184 is divisible by 3. C. 17,90,184. 84 is divisible by 4. So, 17,90,184 is divisible by 4. D. 17,90,184 is divisible by 2 and 3. So, it is divisible by 6 also. E. 17,90,184. 1,79,018 minus 8 is equal to 1,79,010. Is not divisible by 7. So, 17,90,184 is divisible by 7. F. 1,79,184. 184 is divisible by 8. So, 1,79,184 is divisible by 8. G. 1,79,184 is equal to 1 plus 7 plus 9 plus 0 plus 1 plus 8 plus 4, which is equal to 30. 30 is not a multiple of 9. Hence, 1,79,184 is not divisible by 9. H. 1,79,184 is equal to 1 plus 9 plus 1 plus 4, which is equal to 15. 7 plus 0 plus 8 is equal to 15. 15 minus 15 is equal to 0. So, 1,79,184 is divisible by 11. Common factors and common multiples. Example 1. Find the common factors of A. 20 and 28, B. 15, 25 and 45. Solution. A. 20 and 28. Factors of 20 are 1, 2, 4, 5, 10, 20. Factors of 28 are 1, 2, 4, 7, 14, 28. Common factors of 20 and 28 are 1, 2 and 4. B. 15, 45 and 25. Factors of 15 are 1, 3, 5, 15. Factors of 25 are 1, 5, 25. Factors of 45 are 1, 3, 5, 9, 15, 45. Common factors of 15, 25 and 45 are 1 and 5. Example 2. Find first three common multiples of A. 6 and 9, B. 12 and 18. Solution. A. Multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72 and so on. Multiples of 9 are 9, 18, 27, 36, 45, 54, 63, 72, 90 and so on. Common multiples are 18, 36, 54, 72. First three common multiples are 18, 36 and 54. B. Multiples of 12 are 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144 and so on. Multiples of 18 are 18, 36, 54, 72, 90, 108, 126, 144. Common multiples are 36, 72, 108, 144. First three common multiples are 36, 72, 108. Example 3. Which of the following are co-prime? A. 18 and 35. B. 81 and 16. C. 216 and 215. Solution. A. 18 and 35. Factors of 18 are 1, 2, 3, 6, 9, 18. Factors of 35 are 1, 5, 7 and 35. Common factor of 18 and 35 is 1 only. Thus, 18 and 35 are co-prime numbers. B. 81 and 16. Factors of 81 are 1, 3, 9, 27 and 81. Factors of 16 are 1, 2, 4, 8, 16. Common factor of 81 and 16 is 1 only. Thus, 81 and 16 are co-prime numbers. C. 215 and 216 are two consecutive numbers, and two consecutive numbers are always co-prime because they have no factor common except 1. Prime factorization. The process of expressing a number as product of prime numbers only is called prime factorization. Example 1. Find the prime factorization of 90. Solution A. 90 is equal to 2 multiplied by 3 multiplied by 3 multiplied by 5. This is called factor tree method. B. This is called division method. Example 2. Find the prime factorization of 490. Solution. Division method or factor tree method. Thus, 490 is equal to 2 multiplied by 5 multiplied by 7 multiplied by 7. Highest common factor. We have learnt to find common factors of any two numbers. Now, we will find the highest of these common factor. Factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. Factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. Common factors are 1, 2, 3 and 6. Highest common factor is 6. Lowest common multiple. The lowest common multiple of two or more given numbers is the lowest or smallest or least of their common multiples. Multiples of 24 are 24, 48, 72, 96, 120 and so on. Multiples of 30 are 30, 60, 90, 120, 150 and so on. Lowest common multiple is 120. Prime factorization method of finding HCF and LCM. Example 1. Find HCF of 48 and 64. Solution. 48 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. 64 is equal to 2 multiplied by 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 2. HCF of 48, 64 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2, which is equal to 16. Example 2. Find LCM of 40, 48 and 45. 40 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 5. 48 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. 45 is equal to 3 multiplied by 3 multiplied by 5. LCM of 40, 48, 45 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5, which is equal to 720. HCF and LCM by division method. We can find HCF of two or more numbers by dividing the greatest number by another number and then dividing another number by the remainder. Go on repeating the process of dividing the preceding divisor by the remainder till we get remainder as 0. The last divisor is the required HCF of the given numbers. This method is long division method of finding the HCF of two or more numbers. We can also find HCF by division method. To find LCM of the two or more numbers by division method, we proceed as A. Write all the given numbers in a line separating them with a bar. B. Find the number which divides at least two of the given numbers. C. Divide the numbers which are divisible by the numbers chosen in step B and write the quotient below each of them. Write down the number as such if it is not divisible. D. Repeat steps B and C till we get all coprime numbers. Example 1. Find LCM of 15, 20 and 30 by division method. Solution. Thus, LCM of 15, 20, 30 is equal to 5 multiplied by 2 multiplied by 3 multiplied by 1 multiplied by 2 multiplied by 1, which is equal to 60. Example 2. Find HCF of 54, 108 and 144 by long division. Solution. Let us first find HCF of any two numbers, 54 and 108. So, 54 is the HCF of 54 and 108. Now, we find HCF of 54 and 144. The HCF of 54, 108 and 144 is 18. Applications of HCF and LCM. The following examples will explain the use of concepts of HCF and LCM. Example 1. Renu purchased 2 bags of fertilizers of weights 75 kg and 69 kg. Find the maximum value of weight which can measure the weight of the fertilizer exact number of times. Solution. To find the weight which can measure the weight of fertilizer exact number of times, we need to find the HCF of the two given weights of fertilizer bags. 69 equal to 3 multiplied by 23. 75 equal to 3 multiplied by 5 multiplied by 5. HCF is equal to 3. Hence, 3 kg is the required weight which can divide 69 kg and 75 kg exact number of times. Example 2. 3 boys step off from the same spot. Their steps measured 63 cm, 70 cm and 77 cm respectively. What is the minimum distance each should cover so that all can cover the distance in complete steps? Solution. To find the minimum distance each should cover so that all can cover the distance in complete steps, we need to calculate LCM of 63 cm, 70 cm and 77 cm. We will use division method to find LCM. 9, 10 and 11 are all coprime. LCM 63, 70, 77 is equal to 7 multiplied by 9 multiplied by 10 multiplied by 11 is equal to 6930 centimeter. 6930 centimeter is the minimum distance they should cover in complete steps. Example 3. Determine the smallest 3-digit number that is exactly divisible by 6, 8 and 12. Solution. We first find the LCM of 6, 8 and 12 and then we will find the smallest 3-digit number which is exactly divisible by their LCM. LCM of 6, 8, 12 is equal to 2 multiplied by 3 multiplied by 2 multiplied by 2 which is equal to 24. Smallest 3-digit number is 100. Now we will find a number that should be added to 100 so that it is exactly divisible by 24. Number just greater than 100 and divisible by 24 is 100 plus 24 minus 4 which is equal to 100 plus 20 which is equal to 120. 120 is the smallest number of 3 digits that is exactly divisible by 6, 8 and 12. Example 4. Determine the greatest 3-digit number exactly divisible by 8, 10 and 12. Solution. To determine the greatest 3-digit number exactly divisible by 8, 10 and 12, we will find the greatest 3-digit number exactly divisible by LCM of 8, 10 and 12. Now we will find the LCM of 8, 10 and 12 by division method. LCM of 8, 10 and 12 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 5 multiplied by 3 which is equal to 120. Greatest 3-digit number is equal to 999. So 999 minus 39 is equal to 960 is the greatest 3-digit number exactly divisible by 8, 10 and 12.